So I'll be continuing with our playlist, but before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So in this video, we will be talking about deletion of a node in a linked list and insertion of node in a linked list. And we'll be solving 4 different varieties for deletion and insertion. So overall, we will be solving 8 different problems in this particular video. So the video might be long, but do watch it till the end because you're going to learn a lot of things. So the first one, deletion of a node in a linked list, and the first variety is deletion of the head. So how does a linked list look like? Something like this, where you have a head which is pointing to the starting point of the linked list, and after that it is pointing to the next, it is pointing to the next, and then it points to the null pointer, right? This is what we have learned in the previous lecture. So the question is to delete the head of the linked list. So basically, this is something that you have to delete. That is the starting point. How can you delete it? You can say that, hey, in a linked list problem, we always store the head because that is where it starts. What if we move the head to the next? If we move the head to the next, so technically, the linked list will start from here. Can I say this? Technically, the linked list will start from here. Yes, but this node will still be there. The question was to delete it. So how can you delete it? Can I say, what if I keep something? By the way, we always write functions. Imagine we are writing a function which will be returning the new head. Delete head. Can I say it will be taking the head of the linked list? Perfect. How can I delete it? Maybe I'll keep the node temporary as head. Why do I do that? I'll tell you afterwards. So we'll keep it temporary, which is pointing to the starting. After that, what I'll do is I'll say head, can you move to the next? Head will move to the next. So it moves to the next. After this, so when you move head to next, what happens? This one. So if you go ahead and say, hey, return head, that's going to work because this function is expected to return the head of the new linked list, and the head of the new linked list is this. This is okay, and this will work correctly because the program now assumes this is the starting point and this is the entire linked list. This is still there. So you need to free this memory because this is still there in some part of the heap, right? So what you say is, in C++, there is something as free, and you can call free temp. That is how you can free a head of the linked list. So you can either write free of temp, or you can go ahead and write delete temp. That will also work. Now, this is in C++. In Java, this particular line is not required. You don't have to manually free that space because in Java, we have something as garbage collector. Remember the term? Garbage collector. So what happens is, you don't write this, and this temporary is somewhere in the heap memory. Whenever the garbage collector will run, and it will see that there is no reference to this, like in the program, there is no reference to this one. It will delete it, and it might not be an immediate operation. It might happen sometime in the future, but you don't have to worry. Java takes care of it. Whenever there is a memory issue or whatever, it will take care of it. You do not have to do it. But in C++, it is something that you have to do it manually. So I'll try to write the same code, but I'll be covering some more edge cases. We need to write a function that returns the head after removing the head, right? So let's take the head as the function and let's name it as removes head. Imagine if the linked list that is provided to you is empty. In that case, the starting point will always be null, isn't it? So you'll say, what if it is null? In that case, you'll return the same head saying, hey, I don't have any linked list. It is null itself. So that is why I'll return whatever you have given me. Something similar to what you did in arrays. Whenever you got an empty list, you always return that, hey, we can't do anything on the empty list. So this is the edge case that you'll write for all the linked list code. What is the next thing? We'll have to take the temporary equal to head, and then we'll have to say head equal to head dot next. Once I've said this, I need to delete this temporary because this is of no more use. The delete spelling is this, yes. Right after this, I can say return this head. So let's erase this and say node star. Okay, it's converted this. What's the next thing? Node star, or maybe I need the new head, so I can just replace the existing head with removes head. Is that the name? I'll just copy paste. Removes head with the head. This will remove it. After that, I need to print it. So I already have a function which prints my linked list over here by traversing. Now I'll try to run it and see if it is running fine. It does. It removes this head, and now the head is starting from 587. So what I'll do is I'll quickly take this code into the Java, and I'll write private static, copy paste it, remove this, remove this. This will be small, and remove this, head.next. You don't have to delete it, so no need to store in temporary. Done. Once you've done this, call the head to be removes head, and then pass on the head. After this, call the print function, pass on the head, and let's see if it prints or not. It prints 568. Super simple. So in Java, you know the differences now. You don't have to free it. So this is how you can delete the head of the linked list. So we are done with the head. Now let's try to do the tail of the linked list. Delete the tail of the linked list. So if I go back to the linked list, the head is pointing to the starting position of the linked list. And can I say that the tail is this? So once you've removed this, this should be pointing to a null pointer. How do I remove it? Can I surely say, if I'm able to stop before, again I repeat, if I'm able to stop before the last element, in that case, I can say this one, let's assume this is a temporary element. I can say this temporary to point to null. I can say this temporary to point to null. Can I say this? I can. So what I need to do is, I need to stop before the last element. I need to stop before the last element. So if I'm stopping before the last element, what does that mean? The linked list in minimum has 2 elements. Then only I can stop before the last. If we had a linked list which is simply like this, if we had this one element linked list, can I stop before the last? No. In that case, I'll have to delete this because it's a linked list with 1 element. So can I say for linked list with 1 element, because that 1 element will be the head, that 1 element will be the tail. So I delete that 1 element. So what will be the case? Let's quickly write down the function. Again, I'll write node star, delete. This time I'll write delete tail. And I'll take the head. After deletion, you have to return the head of the linked list. So can I say the first thing that I'll do is, obviously the first case, what if it is null itself? If it is null itself, then I'll return null. And because if it is empty, I return whatever I've been given to. Or if the head.next is null, what does that mean? This means either the linked list is empty. This means it only has 1 element and the next is pointing to null. In both the cases, I'll return null because if I delete 1 element, there will be no linked list. So what I'll say is, in both the cases, I will be returning null. That means I don't have anything. The linked list is gone. That's what I'll return. What is the next thing? Apart from this, a linked list always has a minimum of 2 elements. So I'll have to stop at the second last element. How can I stop at the second last? It's very simple. The next dot next. If I write, imagine this is temporary. If I write temporary dot next, where does it point to? It points to null. I'm standing at the second last element and I'm saying temporary dot next, which means last, and then that's next, which means null. So you're saying dot next. So what I will write is, hey, listen, while temporary dot next and dot next, if that's not null, I will keep on going. Or else I'll stop. So what happens is, you keep on going. I'll show you how it goes. It's very simple. What happens is, you initialize the temporary to head. So maybe initialize it here. Node star temp head. Why do we do it? Because we don't want to alter the head. We don't want to do anything to the head. We need to preserve the head, because that is what we have to return. We have to return the head of the linked list. So we cannot alter that. So we preserve it. That's why we put it into one mode. We take a copy of it and then we do whatever we want to do with the copy. So the temp is standing here. What will happen? At first, temp.next, is it null? Is it null? No, it is not. So what will happen? I'll say, temp, can you move to your next? Temp, can you move to your next? He says, happily, I'll move to the next. Perfect. I'll move to the next. What is the next check? I say again, temp.next, that is what it checks. .next, is it null? No, it's 3. Again, move temp.next. Let's move. So I take temp here. What is the next job? Temp.next, .next. That is the check. Is that null? Yes, that is null. So the while loop is done. I don't move. And once the while loop completes, the temp is standing at the second last element. The temp is standing at the second last element. What do I need to do? I need to remove the tail. I need to remove the tail. So can I say, I'll simply point this to null and that will be removed. But this is an element. I need to free it. So what I'll do is in C++, I will say free temp.next. Why? Because I know what is temp.next. Temp.next is 3. I'll free it. I'll delete it. In Java, you don't have to. Garbage collector will do it for you. And then you'll say, temp, your next now can point to null pointer. That's what you can say. Your next can point to null pointer. And once you have done this, what will happen? This will point to null pointer. This will point to null pointer. Done. Everything is done. Now you simply return the head, because in every question you will be returning the head of the modified linked list. So you return the head, and that is how the program will look like. Simple. Let's quickly get back into the code editor. I'll remove this because I want to remove the tail. I'll write node star, remove tail. I'll take a head of the linked list, and we'll also return the head of the linked list. So the last statement will always be this. What's the first thing? If the linked list is empty, so kindly check for it. That's this statement. Or if it's a single element, which is this. In both the cases, I can go ahead and return null. Quite simple. Or else I say node star temp equal to head. I store a temporary and I say temp dot next, and the next is equal to null. In that case, sorry, not equal to null. In that case, keep on moving because it is not the last element. That is what you do. After this, temp will be standing at the second last. So you need to delete the last, right? So maybe what you can do is you can say delete temp. So the last one is deleted. After this you say the next, my bad. Temp dot next should be pointing to null pointer. And once you've done this, you can straight away return this. I think this should be running fine. Let's quickly check it off. So what I'll do is I'll remove the tail and I'll pass on this head and I'll replace this head. So this is the head of the new linked list. I've removed the tail and then I've asked it to print. So basically 7 should be removed. Let's see if it is working. It is working. If you carefully see, I removed the tail and then I'm printing it. In order to check it, what I'll do is I'll take this code. So in order to check this, what I'll do is I'll copy paste this code and I'll go to UX, which will be very similar in your online coding rounds, because this is all you will be getting. You'll not be getting this int main. You'll just be getting this, and this is where you have to write your code. That's it. And so I'll quickly submit this. Maybe I can straight away submit because I'm confident. Yeah, it does run. So going back, let's convert this into Java. Again, let's quickly copy paste this, the same thing. Let's write private static Done. Let's remove this. Let's make it this. Let's do it null. Let's convert it to null. Let's remove the star. Let's return null. Let's remove the star. Instead of this, let's write this. Instead of this, let's write this. Instead of this, let's write this. This will be dot. This will... Okay, we don't need to do this. If we can just point it to the next null, that should be okay. So let's point it to null. Done. Yes. So instead of this, let's remove the tail and let's not try to run. I think it should be good. Yeah, removes it. The logic stays the same. We just remove something and it starts working. So this is how you can remove the tail from a linked list or delete the tail of the linked list. So this one is done. Let's try out this one. Over here, you'll be given k. So you'll have to delete the kth element of the list. What does it mean? Imagine k is given as 5 and the length of the list is 4. So in that case, you'll not be deleting anything because this value exceeds that one. So you'll not be deleting anything. Let's check out the next thing. What if k is 1? In that case, we boil down to the first problem, that is deleting the head. What if k is given as 4? In that case, we boil down to the problem where we delete the tail of the linked list. What if k is given as 2? What if k is given as 3? In that case, you boil down to the problem where you delete any of the middle nodes in the linked list. So you'll have to write an algorithm that deletes maybe the head, maybe the tail, maybe any other node, or maybe nothing. You'll have to combine all of them into one. And what you'll be given is the kth element, basically second element or the third element or the fourth element. That is what you'll be given. How can I think of it? So always in linked list problems, you start thinking of edge cases and then you build on it. Never ever try to think of the algorithm. What can be the minimal thing that I can think of? First thing that I can definitely think of is, what if k is 1, which means I've been asked to delete the first element in the list. In that case, we straight away delete it. So can I say, while I start, let's try to write the code and slowly we'll try to improvise. So again, we will be returning the head of the linked list. So node delete k. And you'll be given the head of the linked list, definitely. And you'll also be given the k. So can I say one thing for sure? What if the list is empty? That's always our edge case. If the list is empty by any chance, we do not do anything and we return whatever head is given to us. That is the edge case that you'll write every time. After that, let's try thinking. So I've written down the basic edge case. Let's try to think about the next edge case. What if k is 1? In that case, it is always the head of the linked list that I have to delete. So can I write something as, hey, if k is 1, in that case, you'll have to implement a logic. What will be the logic? You'll have to move head here because that is the new head of the linked list. And at the same time, you'll have to delete this. So obviously, we need a reference of the previous one. So maybe let's remember the current head at first. So what we have done is we'll remember it. Then maybe let's move the head to the next. So head will move to the next. Over here, you can straight away return the head because this will be your head of the new linked list. You can straight away return it. Or what you can do is you can free this particular temp stating there's nothing. Just free yourself. After that, you can go ahead and return the new head. So that's how you'll do it. In case you don't want to do the free step, this will go and this will go. You just move the head to the next and you return the head. So this is what will be done when k is 1. So I've written down the case for k is 1. What after that? What if I've been asked to delete, let's say, the third element, which is basically this. Let's quickly erase this at first. And the head will be here. What if I've been asked to delete the third element? How will I delete any particular third element is the question that should come to your head. So if k is 3, which is basically this element, what happens? Let's analyze. If this goes, what happens? In that case, this link will be linking to this, isn't it? Because previously this was pointing to this and this was pointing to this. If I go across and delete this, this should straight away point to 3. This should straight away point to 3. So somewhere I have to reach here. That's something which I've understood. Somewhere I have to reach k equal to 3. At the same time, what do I need? If I'm standing here, I need the previous, and then I can say the previous next will be, because this guy's next will be what? Previous, next. Can I say this? I repeat. If I'm standing here, which is k equal to third element, and I remember what is my previous, can I say previous, next, which is basically meaning I'm saying this next will be pointing to this, which means previous, next. That is what I can straight away write. Can I write this or not? I can write this. And this is what I'll try to write. But before that, let's think of one more case, which is k equal to 5. What if k is 5? In that case, you start the counter from 1, you reach the counter 2, you reach the counter 3, you reach the counter 4, and you stop. So you'll never find 5. In that case, you straight away return. So that will be the case. Alright. So we need to stop over here. We need to stop over here somehow. So let's maybe initialize, let's maybe initialize temporary equal to head, which is basically this one. And at the same time, let's initialize a counter equal to 1. So I've initialized the counter equal to 1. Let's try to write the code. So I'll try to write the code. So counter equal to, because if this if has executed, it will return. Counter equal to 1, or maybe I can put it as 0, whatever is your choice. Counter equal to 0. I say temp, maybe write a node star temp equal to head. So what I've done is, I've done the basic initialization. Basic initialization is done. What is the next? To traverse? You know how to traverse. Everyone knows. So when I enter, I will always check if temp is not equal to null. If that's the case, which means I'm still in a linked list. I'm still in one of the elements of the linked list. Hence, I will increase the counter. So what happens at this step is, you basically check, hey, are you an element? He says yes. So you increase the counter to 1. You increase the counter to 1. Once that is done, you need to remember, you need to be sure, hey, are you the element? Hey, are you the element? You need to remember this. So what you will say is, hey, counter, are you k? If you are k, then it's okay. If you are k, then it's okay. We will do something if you are k. If you are k, we know what to do. We will have to say previous dot next equal to previous dot next dot next. But now you might be thinking, but Striver, where is previous? I don't have a previous. So I'll have to keep previous. I'll say maybe keep a previous which is initially null, which is initially null. So initially previous is null, which is somewhere here. So let's assume previous is here. What happens? Counter increases. So counter is 1. Is that equivalent to k equal to 3? No. So I'll have to move. I'll have to move ahead. So this if doesn't works. If doesn't work, and if this if doesn't works, which means there was a break statement, it doesn't work. In that case, you will say temporary, can you move ahead? Basically, you perform the traversal algorithm. So we move ahead. We simply move ahead, right? So what are we doing? We are saying temporary, count 1 is not 3. Count 1 is not 3. So can you move ahead? Sorry, my bad. So can you please move ahead? He says, why not? I'll move ahead. But wait. I need to remember this. I need to remember the previous. Yes, very good, very good. So previous equal to temp. Right before moving, remember it. So what happened? You remembered the previous and then you move the temporary. Again, the while loop will happen and then it will do a counter plus plus. So when you do a counter plus plus, counter will become 2. and the counter 2 is not equivalent to 3. It's not equivalent to 3. So what will happen? This will move. But before that, the previous will move here. Then the temporary moves. Done. Again, the while loop will be checked. What happens? It's still an element. So the counter increases and becomes 3. When the counter becomes 3, it's equivalent to k. It's equivalent to k. So what you're doing is you're saying it's equivalent to k. So previous dot next. Hey previous, you're next. Previous, you're next. He says yes. My next will be pointing to my next, which is 3. So it points to that. But you still have a temporary. So before breaking out, please make sure you free that temporary and then you break out. Very, very important that you free that. Once it is done, you can straight away return the head of the linked list, which will be your answer. Done and dusted. In case you never execute this, k was greater. You didn't find it. K was greater. Quite simple, isn't it? What if k was 4? If I write k as 4, let's write it. If k was 4, in that case, temporary would have stopped here. Previous would have stopped here. Previous's next would have been pointing to previous's next of next, which is null. Automatically, the tail also gets deleted. So in this way, you can also delete the tail. So let's quickly write down the code. So what I'll do is I'll remove this. And then I'll write node star remove k. I'll take the head as usual. And I'll take the k. First thing is, if the head is null, obviously, don't need to do anything. You can straight away return, by the way, capital null. You can straight away return whatever was given to you, which is null. If k is 1, in that case, you remove the first one. So what you do is you say head, or maybe you can just store the temporary so that you can free it afterwards. You say head equal to head dot next. At the same time, you say free temp, and then you return the head. Quite simple. Otherwise, you take a count equal to 0. You take a temporary equal to head. You take a previous. Just take a previous, which is null as of now. Perfect. Okay. What's the next thing? Let's go across and traverse in the linked list. So temp is not equal to null. I will be traversing counter plus plus. If at any moment counter is equal to k, that means my temporary is over there. So I say previous dot next equal to previous dot next. But before that, please free temp and then break out. At the end of the day, you can straight away return the head of the linked list. Quite easy. Otherwise, you store the previous to be temp and you move the temp to the next, which is something like this. Once you have done this, maybe I can remove k now, or I can say node, or maybe just head equal to remove k. So let's call this function and ask this function to remove from this linked list, let's say this third element, and let's see if it works. Let's run it. I hope it runs on one go. Oh, it runs. So 8 is removed. Let's try to remove the first element. Yeah, the first element is removed. Let's try to remove the last element. My bad. It does. Can I remove the second? It does. You can try for out of bound. Maybe I'll give something like 7. Let's see if it deletes anything. No, it doesn't. Wow. That's it. It works for all of the edge cases. Got it? So this is how you can remove it. Again, Java. Shall I write? Shall I not? This is the last time I'm writing for Java. Because I'm assuming you guys are smart. Which you are. So, okay, this is done. This is done. This will be null. This will be null. This. Look at my speed. This will be dot. No free there. So remove it. This will be dot. Doing done. And now we can go ahead and say remove k head. And let's say 3. And let's say print it. Yeah, it's removed. Super simple. So what is the time complexity? We go of k, whatever is the number of elements, you'll have to go through it. So big of k is your time complexity. By the way, you can remove this node temporary. We don't need it. Perfect. So let's go back to the code, or rather go back to the iPad and see that this one is done as well. What is the next one? Depending on a value, what does that mean? It means you might be given this value 9. You might be given this value 9. You'll have to remove depending on the value. Isn't it the same problem that we did over here? This is dependent on the index or position. Over here, we have been asked for value. What changes will I do? Let's go back to the code editor, because I'll be explaining you the changes in the code editor. It's quite simple. This stays the same. Now, instead of k, how can I determine that the value passed? Oh, sorry. Let's maybe copy paste this. Remove element. Let's say remove element, and you're given an element. So this stays the same for sure. How can I determine that the head is the element itself? So instead of k equal to 1, can I say head dot data is equal to element? If that's the case, I do nothing. I do the same thing, isn't it? If that's the head, I do the same thing. And instead of taking a count, because I know the element, I cannot do a linear search. And I've been asked to remove the first node with that element. I've been asked to remove the first node with that element, right? So what I do is I say, hey, I don't need a count plus plus. I don't need to check for this. Instead of this, I can straight away check if the data is equal to element. If that's the case, I can straight away delete it, and that's it. So if I say remove element, let's see. I say remove element, I ask them to remove, let's say 8. Let's see if they remove it or not. Let's try to play it. It does. If I ask them to remove 5, do they? They do. If I ask them to remove 15, can they? No, they cannot. That's how it works. You just modify the changes and it works for it. So now go back to the code editor. So I can say that the deletion is completed. Now, if you understood deletion in depth, this is going to be super simple. So let's try. Let's start with the first one, that is inserting at the head of the linked list. Imagine I give you an element as 5 and I ask you, can you insert this 5 at the head of the linked list? What that means is, doesn't mean doing this. No, it is not replacing the head. It means you'll have to insert it over here, and the new linked list should look something like this, where it is starting from 5. How can you do this? Isn't it very simple? Previously, your head was over here. You just need one more node over here, which has 5, and it pointing to 2, and the new head being over here. Can I do this? I can. I'll say, I'll create a new node. I'll put 5 into it, and I'll call this as temporary. And this temporary next will point to the head, and in the function, I will return the temporary stating that this is my new head. I'll return the temporary instead of head. I'll no more return head. I'll return the temporary, and I can replace the head of the linked list, saying temporary is my head of the linked list. Can I do that? I can't. So let's do it. So what I'll do is I'll quickly get back to the code editor and I'll say insert head. And over here, the first thing I'll do is I'll take the node star head and I'll take the element, which I can call as val. What is the thing that I'll do? Let's create a temp, because that is what we need. New node, val, and initially, can I say it should be pointing to, like the next should be pointing to head. I can say that, and that is how our constructor looks. Takes the value, takes what is the next. Done. And I just return temporary. That's it. One liner. So instead of doing this, can I say head will be, the new head will be after inserting on the head a value of, let's say 100. If I do it, and after that, if I print, let's see, oh, sorry, my bad. I have to pass on the head as well. Let's play it. You see 100 is inserted. It is. You just call it. It does it. Instead of writing this, you can straight away write this as well. Yes, you can straight away write this as well. That's it. Instead of doing this, instead of calling this, you can also write this. This will also do. because you're saying head equal to new node. So the new node is automatically creating a new node and pointing to the head. So you can do it in either of the ways. That's a big O of one complexity. So this is how you will be inserting right before the head. Let's come to the next thing. So we're done with the head. Let's come to the next thing, which is inserting at the last. How do I insert at the last? What does it mean? It means you will have to insert 5 here, and then it will point to null. So have to add one more element at the end. So the linked list will be increasing in size. How do I do it? The easiest way is I say, hey, listen, let's take this head to here, this head to here, this head to here, and then we will think what to do. We will not be skipping anything, right? So I can probably say, hey, let's take a temporary. Let's try to move it because I will never ever tamper with the head. Let's try to move it. Temporary moves here, temporary moves here, and temporary moves here, and we stop. Whenever we see that the next is pointing to null, we will stop. I repeat, whenever we see that the next temporary's next is pointing to null, not temporary. Generically in traversal, you stopped when temporary was null. When this temporary was reaching here, that is when you stopped. Over here, we stop when temporary's next is pointing to null. That is when you will stop. Before that, you will not. So temporary is over here. What is the next job? Just create an element. So basically create one more node and then ask the temporary to point to this. And that's what you have to do. That is what you have to do. Yes. So let's do it. So can I say node star insert tail will be, I'll take the head, obviously. I'll take the value. At the end, I'll be returning the head. And can I say, one thing you will definitely say is, if head is null, which is basically, it's an empty one. It doesn't have anything, which is the edge case, an empty list. In that case, you will end up returning a new node of this val and a null pointer. So that's it. A single element is created because it didn't have anyone. You just return it. Same thing will work for insert head. If it had nothing, then the head will be null. And you just create a val. Over here, you do the same thing. But what if it has? In that case, you'll have to take a temporary with a value head. And then you will be going till the next is not null. Very, very important. Not temp null. Temp next. So that you stop at the last element. So I stopped at the last element. What is my next job? Let's create a new node. Saying new node with this value. And let it point to null because it's the last element. So it should point to null. Once this is done, can I say temporary next will be pointing to this particular new node? I can. Done and dusted. So I can say, instead of insert, I can say this. And now let's see if it works. You see, it's inserted at the tail. So quite simple. So you're done with the last one. It's now time to do inserting at a given kth element. Over here, k will always be from 1 to n plus 1. What does that mean? Over here, the length is 4. So k will be from 1 to 5. It cannot exceed 1 to 5. If it exceeds, you need to print some message or something like that. So imagine I ask you, I'm giving you an element like 10, which is this, and I'm asking you k equal to 1. What does that mean? That means you have to insert at the head. So you insert 10 over here, and this points to this, and this will become your head. Got it? Imagine k is 2. In that case, your linked list will have 10 here, and it will be pointing to this, and then it will be this. So this link will go off. It goes between 3 and 1. It has to be the first element. It has to be the second element in that case. Got it? What if k is 3? In that case, it has to be the third element. So you'll insert 10. This will point to this, and this will point to this. This link will go off. This is the first element, second element, and the third element. What if k is 4? In that case, it will be somewhere here, right? What if k is 5? In that case, it will be somewhere here and this will be null. 1, 2, 3, 4, 5. That is why it cannot go beyond 5. If it is beyond 5, you probably will print something. How do we do this? Multiple cases again. Let's go one by one. Whenever you get linked list problems, try to think case by case. So how do we solve this? Now, there are a bunch of edge cases. What's the first edge case? What if the linked list is an empty one? Like it doesn't have anything. You need to think about that. In that case, if the linked list has nothing, like it has nothing, you can only we can only insert at the first position. We cannot do anywhere else. Correct? Okay. So let's try to think about that at first. So as usual, we will be returning the head of the linked list after inserting. So insert at k, you'll be getting the head, you'll be getting the element, you'll be getting the k for sure. So can I say if the head is a null, which means you're getting an empty linked list. In that case, what will you do? In that case, you'll just create a node and that will only be valid for k equal to 1. For all other cases, you don't do anything. So you'll just create a node, new node with the value element because it just has 1 and you can straight away return this. You don't have to do anything. If k is 1, you do it. Otherwise, it's a bug. It's an error. You can't do anything. And maybe you can just return null or something like this. Because otherwise, it's not possible. You can print a message or return whatever you want to do. Whatever you want to do, I'll leave that on you. Okay. What's the next thing? What if there is a linked list? What if there is a linked list? I've been asked to, let's take this case, where element is 10 and I've been asked to insert at the first position. So again, same thing you write. If k is 1, which means I've been asked to insert at the first element. I've been asked to insert at the first element. So we will do that. We will say node star temporary equal to new node. And this will be the element. And we will pass on the head to be the next. We will pass on the head to be the next. So element goes and it points to head. Once that is done, I can straight away return temp. So this is what will happen if k is 1. So insertion at head was super simple. What about others? What if I just go ahead and say, hey, what if k is 3? In that case, it's somewhere between 1 and 5. In that case, it is somewhere between 1 and 5. So can I say, if I stop the temporary somewhere here, if I can stop the temporary somewhere here, my job will be done. Why? After this, I can create a new node. I can do that. I can put 10 into it. What after this? I have a temporary. Temporary is next, I'll point here. Temporary is next, I'll point here. And the 10's next, I'll point to 5. Can I do this? I can. But I have to be careful. First, let's try to go and stand here. Let's try to take temporary here. Which number element is this? This is the second number element. So I'll go and try to stand at the second number element, which is 1 behind the third. So maybe let's try to traverse. Let's try to give counter equal to 0 and temporary equal to head because we do not alter the head. And now try to traverse. So what will be a traversal? Obviously the temporary, you traverse till the end. So till it is not null. And you basically do counter plus plus. One thing for sure. The head is done. So you're dealing for k equal to 2 and greater than 2 cases. K equal to 1 case is done. You're dealing for k equal to 2 and greater than 2 cases. So what I'll do is, counter is done. So what will happen at the first instance? Counter will boil down to 1 and temporary will be here, right? So what will I check? I have k equal to 3. Is it 1 behind Is my counter 1 behind k? Let's check it. If my counter is 1 behind k, then I'll do my job. Yes, I will do my job. Otherwise, I will just move temporary to temporary next. Quite simple, and this is how the while loop will end. So what will happen? Since counter is 1, it moves temporary here. Never ever alter it. What will happen next? It goes ahead and checks, is temporary null? Is it? No. Counter increase. He'll say, okay, I'll increase. Don't worry, I'll increase. Counter 2. What does it check? It checks for 2 equal to 3 minus 1. Yes. What is your next job? Let's do it one by one. I will try to create a box, or rather a node, and insert that element. In this case, n. So try to create that node, which is node star, whatever you want to call x, new node element. Done. Can you tell me, if I say temporary dot next equal to 10, if I do this, so basically what I'm doing is I'm omitting this and I'm straight away doing this. I'm saying temporary dot next equal to 10. If I do this, will I have any reference or any pointer to 5? I will not have. Hence, I'll not be able to do this. Because I do not have any pointer pointing to 5. Hence, I'll not be able to do this. So I'll have to think that, hey, listen, I cannot break this because this is what tells me there is 5 after 1. This is what tells me. So what I'll do is I'll say tens next is temporaries next. I will say tens next is temporaries next, which means what is temps next? What is this? This goes, what is temporaries next? 5. So first connect this. So what I'll do is, first I'll say x next equal to temp next. That's the first thing I'll do. After that, I will say temp next, go to 10. After that, I will say temp next, go to x. Once I've done that, I already have my head. So I'll return my head, which is whatever the head was. In case you exceed this, you have reached out till the end, which means the k might have been greater number or something like that. So this is how it will look like. Very simple, very easy. Or you can straight away, because you'll have to write multiple return statements, so you can straight away write break, which will break out of the while loop, and at the end of the day, you can return the head. Simple. This is where the function ends. This will be covering all the edge cases. Yes, it will be. So this is done. What is my next job? I'm going to the code editor and writing the code. So node star insert at position, given the head, given the element, and given the kth position. So the first thing, if head is null, which means an empty list, only if k is 1, then only I will create a new node with this element and I'll return, or else I will simply return not possible or a null or whatever is the linked list. Depending on the problem statement, you can do it. This is not possible, by the way. If k is more than 1 in an empty linked list, it's not possible. What's the next thing? Maybe. Let's see if this is insertion at head. If that is insertion head, I'll do it. Yes, I'll do it. I'll say node star new head, because this will be my new head. New node, this element will go, and this will be pointing to the previous head because the head has changed. And I can straight away return this, or I can straight away write this. Quite simple. Done. Or else I say counter equal to 0. This is what I'll say. Counter equal to 0. After that, what will I write? Node star temporary is what I need. So I'll put this here. After this, while I'll go ahead and say temporary not equal to null. Counter plus plus. If counter equal to k minus 1. In that case, I say node star x equal to new node What is the value? Element. And after this, you are writing something as elements next is equal to temporaries next. Can I straight away say, instead of writing this line, I can just put it here? Because that is what it does. It creates an element whose next is pointing to this. Done. Once I've done this, can I say temporaries next will be pointing to this particular x, and then I can straight away return, or maybe I can just break. Over here, it will be moving to next. So please move to the next. And right at the end of the day, I can return the head. And yeah, this is done. So I've insert position. Let's see. Insert position head 100. Let's try to insert it at 1 and see if it is running fine. It does. Let's try to insert it at 2 and let's see if it runs fine. It does. Let's see for 3. It does. Let's see for 4. It does. Let's see for 5. It does. Wow. Let's see for 6. It will not do anything because it's an invalid number. Got it? This is how easy it was. It was. What is the time complexity? Obviously, depends on the best case. If it is head, it will be bgo of 1. If it is traversing, it might be the last. Bgo of n at the worst case if you end up traversing the entire linked list. Right? So we're done with this one. Let's do the next one, which is the value stuff. So basically the question is inserting an element before the value x. What does the question mean? You're given an element n, which is something that you have to insert before the value that is in the linked list. So there is 5 in the linked list. You will have to enter this value n. So I go ahead and enter it over here. And it is guaranteed that this value will be there. We will cover up the cases when the value is not there. But it is guaranteed as of now that the value is there. So you basically insert 10 before 5. So it will go over here. And this link will go off. At the worst case, it can be given 8 and you'll have to insert it over here. At the best case, you might be given 3 and you'll have to insert 10 over here. So you'll have to think about all the cases. Isn't it similar to the previous question? It is. Over there, it is given third element. Over here, the value at the third index is given. The value at the third index is given. So can I change the code? I can. So what I'll do is, I'll try to show you how to change the code. I'll just take the same code and I'll try to copy paste and insert, instead of position, insert value. Insert before value, it is a good name. Insert before value. And imagine this is the value given. So can I say if head is null, then can you have a value? Like if the linked list is empty, it can never have a value. So this is kind of an case which is technically never possible. Because if the linked list is empty, how can you find out the value in that linked list? It is technically not feasible, right? You've been asked to insert an element before a value. If the value is not there, it's technically not possible, right? What is this case? What if it's the head? So head data is equal to val. If you've been asked to insert before the val, which is the head, you just do it. Why are you thinking? You just do it and return, saying element and done. Instead of count, what will I take? I will say, hey, temp is your next data. Yes, is your next data equivalent to the val? So what I'm doing is, let's go back to the iPad. I know at the worst case, you might be having 8. In that case, temporary will be here. Temporary's next is this. And the data of this is 8. At the worst case, the temporary will be here. So you got to stop at the second last element. You'll never go to the last element. Because you can stand here and check for the next. So can I say, if I'm not going to the last, I'll simply say if temporary.next is not equal to none. That's what I'll say. And if next.data is equal to val, in that case, what happens? I create the element and I just mark it. I do the same thing. I just keep on going. Only the check changes. Done. Can I do insert before value? Let's see. Insert before value. What do I insert? 100? Let's say before 12. Done. Let's say before 5. Let's check out everything. Done. Let's say before 8. Let's check this. Done. Let's say before 7. Because that is the last one. Yeah. Done. And it's guaranteed that you'll be given a value which is there over there. Like, it is definitely there. You'll always be given it. In case you're not given, you can probably print something if you wish to. This will be this case. And probably if it doesn't breaks over here, if it never breaks over here, in that case, you can probably keep a flag, something like found equal to 1, like maybe give a boolean flag equal to false, found. And you can say if found is false, then is not found, something like this. Print not found. Something like this you can write. Over here as well, you can write not found. So, quite simple. This is how you insert before a value. So, I'll quickly go back into my iPad and this one is done. We have covered up 8 problems like across deletion and insertion in a linked list, and I hope you've understood each of them. Again, you'll find the C++, JavaScript, Java, Python code links in the description. There are supreme quality articles in the description below, so make sure you check it out. And if you're still watching, it took a lot of effort, so please do consider giving us a like. And if you're for the first time here and if you haven't subscribed yet, there's a subscribe button. Please do subscribe to us. If you haven't followed me on Instagram, Twitter and LinkedIn, all the profile links will be in the description. With this, I'll be wrapping up this video. Let's wait.
Whenever your heart is broken, don't ever forget you're golden.